Hello everyone, my name is S.Shahmohammadi and I'm a PhD student at the University of Sherbrooke. And actually, I'm gonna present my research project entitled Assessing the Efficiency of Technical and Non-Technical Strategies in Achieving Zero Emissions in the Building Sector. And this is the outline, and let's start with the context of this research. Actually, regarding to climate change issue, we know that according to the report by IPCC, there is a worldwide compromise to tackle global warming of 1.5 degrees Celsius above pre-industrial levels. And to achieve this goal, actually addressing emissions by the building sector could be a great step, because this sector alone actually accounts for 39% of the global carbon emissions, and out of this amount, 28% includes direct emissions from the fossil fuel, and 11% includes embodied carbon emissions that are mainly produced during the production phase of the building. And in Canada, as an example, this country committed to become net zero emission by 2050. And actually, this is while that only 5 years of energy efficiency is introduced to National Building Code of Canada that ends up with reduction in energy use and at the same time of operational carbon emissions. And we can see that none of the Canadian building codes and regulations concedes embodied carbon emissions. And in this situation, when energy efficiency remains the only metrics, we can say this country won't be able to achieve net zero carbon emissions in the future. And in this slide, these figures show us the importance of reducing carbon emissions, embodied carbon emissions from the production phase, because the majority of the emissions are by load-bearing components made of carbon-intensive materials like concrete, like steel. And by looking at the first figure, we can see that, for instance, foundation is an everlasting component, and structure lasts like 100 years. And this fact could indicate us that, the advantage of some strategies like retrofitting, because in this kind of a strategy, we are not going to build from scratch, we just renovate things. And at this step, we came up with this question: what about other strategies? What are the other strategies that could help us to build nothing or build less to reduce embodied carbon emissions? And with this research question, we reviewed the existing literature, and we came up with this finding that most of the papers currently just focus on technical low carbon strategies, and there is just a few studies that focus on non-technical ones. And here I'm gonna present two of the relevant studies in this field. For instance, in 2022, these others methods they propose 5 types of non-technical solutions named active and passive management, operational and operation, and demand flexibility, sufficient comfort levels, and circular and sharing economy, and also organizational and social innovation. And also they mentioned that sharing economy among these strategies has the highest potential, and also there is no sufficient evidence for none of these non-technical low emission let's say strategies. sorry. And also the next study, these others in 2018, they mentioned the sectors that the sharing economy has been extended, and they put emphasis on sharing economy, the application of sharing economy for reducing emissions as well. These sectors are mobility, such as ride sharing and also building, using this concept for short-term residential buildings and also commercial workspaces. And the last sector is labor. And in this figure, in this slide, we can see the potential of carbon reduction with respect to project development stages. And we can see build nothing could have the highest potential, and the next one is a bit less. And these actually these could refer to prevention principle, which is one of the principles for reduction of embodied carbon that I'm going through them in the next slide. And at the end, we can say the idea of sharing economy could totally be in line with this principle, because in sharing economy in construction, actually, we are not going to build new houses. We just adapt and transform the existing houses to make them suitable for settling another household. And in this slide, I'm going to present the path that we went to for finding research gaps. Actually, by studying the literature about zero carbon emissions in the building, we could categorize them mainly into two groups. The first group, that most of the studies were in that group, they mostly focused on the reduction of operational carbon emissions, and they said energy efficiency strategies can reduce these emissions. And the second group were those studies that focus on embodied carbon emissions. And there are mainly four principles for reducing these emissions. The first principle is reduce and optimize, and it includes some strategies like optimizing the design, using locally available materials, and using low carbon materials. And the second one is offset. The third one is plan for future strategies like design for disassembly is in this is a subset of these principles. And the last one is prevention. And as I said earlier, it has the highest potential because it aims to increase the usage of the existing assets to the renovation and reuse. And at this step, we came up with some potential opportunities. For instance, assessment in a larger scale instead of a building level, and also, as I said, non-technical solutions. And with emphasis on these solutions, we continue our reviewing, and we found out that some studies just consider the changes in the behavior of the occupants. For instance, window opening, water usage, and these kinds of actions actually could finally reduce the operational carbon emissions, not the embodied carbon. And the second group was those studies that focus on sharing economy as a circular approach, and some of them mentioned sharing tools that again it is for reducing operational carbon emissions. And in this regard, some studies mentioned the sharing space in offices and short-term accommodation, as I said. And here the potential opportunities for us was extending the usage of this concept for long-term housing, and also comparing the efficiency of non-technical solutions alongside the technical ones. So based on whatever I've explained, the question of my study is decarbonization of buildings attained just by considering technical strategies, or do not non-technical strategies like flexible behavior or sharing economy also need to be accounted for. And the goal would be extending the application of sharing space for long-term housing and comparing the efficiency of a non-technical strategy alongside of a technical low carbon strategy. And about the methodology, first of all, I should say that we took a proof of concept approach because we wanted to just assess our idea whether it was to go through or not. And by using attributional life cycle assessment, we assess the environmental impacts of our case study. And for this assessment, the system boundary was a single family detached house, and the functional unit was 1 square meter of the studied house's material per 70 years. And the second table is bill of material. It was a long list, and just here I present a couple of those items. And actually, for this assessment, we defined 5 different scenarios. The first scenario was a regular single family house with regular materials, and 60% of heating energy is provided by fuel, and about 40% of energy is provided by electricity. And this is our baseline scenario, and we actually compared all of other scenarios with this baseline scenario. And the next 3 scenario was where our where our technical strategies. For instance, the second scenario is using low carbon materials. We try to decrease the embodied carbon emissions by using low carbon materials in the building. The third one is using recycled material content, and according to LEED Credit 4, we consider 20% of concrete as a recycled concrete aggregate. And the scenario number 4 is for reducing energy. And actually, in this scenario, we decrease energy by improving installation. And the last scenario is our non-technical strategy using the concept of sharing economy, that we transform the interior design of the studied house to make it suitable to settle another household. And also we consider 3 different contexts for these scenarios. For instance, the first one is when our building is using both fuel and electricity. The second one is when a building is all fuel building. And the third one is when we have an all electric building. And this is the graph of the results, and we can see that, for instance, in this context, when the building is all electric, in almost all impact categories, the last bar, which is the non-technical scenario, has the less environmental impacts. And the same is for all fuel building, and also the same for fuel electricity. And finally, we can conclude that based on our approach that it was a proof of concept approach, it shows that the non-technical scenario can bring a higher environmental benefits besides the technical scenario, as it reduces the area by adjusting the house's size to the household size, and also it reduces the overall demand for carbon-intensive building materials, and these lower average floor size result in minimizing heating, cooling, and lighting. And for the future step, we aim to evaluate the effects of other non-technical low carbon strategies alongside the technical ones, and also assessing in the large scale instead of a building scale. So this is the end of my presentation. Thank you for listening, and I just leave the floor for other speakers.